pense pas, enfin, je sais pas, je soulève un ballon pour le faire. Ah bon? Yes. Bruno, mine. Just your phone, no dots. Dots, yeah, but yes. Okay. Elle m'a dit qu'il allait m'envoyer des trucs, mais comme je n'arrive pas à me connecter au réseau. La mise à jour des slides. Ouais, c'est un peu compliqué, non? Non, mais c'est vrai. Il vaut mieux qu'il me l'envoie à moi. Moi, je pourrais l'uploader en plus. Si tu présentes. Ouais. Non? Ouais, bah, je vois. Non, mais quand tu vas faire un temps fou, je vais lui dire. On commence, il est bien. Bonsoir Bruno. Non, ça passe pas. Et t'as besoin du réseau? Non, j'ai raison. Okay, ladies and gentlemen, please be seated. And the last one entering, please close the door. This is the Spring Working Group meeting in Singapore. And the agenda is full. Let's have some fruitful discussions, but please be aware that we might have to cut them at some point. Huh? C'est moi? Ah, I do speak. So, note well, you know it. Please be aware of what's inside for your contribution in this session and more globally in IETF. Any volunteer for the minutes? 1, 2, 3. No, thank you. This is the agenda. I won't go through it. You've seen it on posted a couple of weeks ago. Anyone having concern or having any comments on the agenda? No, we will proceed then. Quick update on different documents. So the working group spent a lot of time trying to push to IESG a batch of 2 batches of 4 documents. They made their way, and this is the status. So the 3 use cases are on the IESG telechat of mid-December, and they are waiting for AD go ahead. Just like routing architecture and routing central EPE, the previous 3 should soon be in IETF last call. So these 2 are in IETF last call and IESG telechat mid-December. These 2, the last remaining 2 are in a different state, and Alvaro needs to get back to us on that. Few words on each of these documents, specifically on the Spring Routing MPLS. You might have seen, if you follow the list, which I hope you do, Alvaro made substantial and complete reviews of the various documents, which are being addressed or have been addressed. But for one of them, namely routing MPLS, Alvaro has decided to return the document to the working group. So we still have work to do on that one. Conflict resolution. So there was a last call, working group last call, some time ago. I'm responsible for that. There were a good number of comments, a lot of discussion, which was good. There is one, however, significant point which was raised and which is still not addressed, which is the possible conflict when in the case of multiple IGPs or routing instances. So it needs to be resolved, and we are investigating ways on how that could be done. Just to update you, the documents that are in IESG have went through significant changes. We didn't change the fundamentals of the documents, of course, but we encourage you to go and read the document, review the changes, because some of them are important. I'm not going through the whole list here. It's for the record and for you to know. But please remember, go and read the latest versions of these architecture documents. They have changed. So that's true for architecture, and that's true for segment MPLS, but segment MPLS, you'll have the opportunity to review it again since it's coming back to the working group. And I'm handing the microphone to Jeff.
So given the overlap with MPLS working group, I'll try to go as fast as I can. 5-minute slot. Please don't ask me the difference with the next presentation. During the third slot, we'll discuss it. So my goal here is to give you a short overview. The objective of the draft is to provide facility to transport packets that are MPLS SR encapsulated over IP network, over IP UDP in this case. We are IP version independent. Both IPv4 and IPv6 provide this facility. We've defined 3 different roles in the network. Node that don't support segment routing, so IP forwarders, SR-capable routers that are not in the label stack, so they're not directly addressed by a seed, and SR-capable routers that are processing SRs. As you could see in the picture, when ingress to the tunnel encapsulates traffic in MPLS and then UDP, it sets next hop to the next label in the seed that resolves internally. The UDP destination port indicates MPLS and UDP in CAP, RFC 7510, so node that is there and is capable of processing this information will do so. So details on encoding. Source, sending SR node, destination, next SR capable node that is in the seed stack. All kinds of seeds that supported today in GP are supported there, so there are no really changes to control plane. So very useful comments with regards to entropy have been received, and indeed there are 2 types of entropy processing. In case when SR capable node that is in the stack is processing entropy, it is looking into entropy labels. When we are in IP processing case, we look into UDP source port that's used to enrich entropy. So it has to be coherent and consistent to avoid reordering. Very important point, transit nodes are not processing SR even if they're SR capable, however, not in SR stack. So key changes from 0.0, a lot of clarification. Clarification with regards to entropy processing are due in the next version. So we believe that draft belongs in MPLS as such. If there are new processing options in regards to new encapsulation, they should be addressed in separate documents. We would like to keep control plane separate from the data plane, so a single set of control plane documents should address all possible encodings in data plane. And by doing so, we can move faster. So the proposal is again to discuss it here. However, we believe since 7510 has been done in MPLS to keep this draft in MPLS as well. And the questions about similarity with next draft are going to be addressed in the third slot. Thank you. Any questions?
Any questions specific to that presentation? Because there is another presentation, and we'll then have a merge slot to discuss both.
Yeah. Closer to the mic. That's valid for all mics. Let's switch data.
K. Patelakis. I just wanted to let you know that it's a fairly simple draft. I went through it. I really like it.
Which one?
The former one.
Okay. In fact, both former and this draft are describing the same technology. So I just quick some details. Okay. Minor changes since 03 version is the coarser number has been reduced to meet the requirement of coarser number limit. Another change is to add some tests to clarify how to word you're performing hash on the whole label when re-encapsulate the MPS SR packet within a IP UDP packet. You can see from this figure, no matter the underlay, the IPv4, IPv6, or MPSR, the source routing or traffic engineering instructions are uniformly encoded as MPS label stack. In this way, it combines the best of the two worlds: the simplicity of IP as an underlay and the flexible programming capability of MPS as an overlay. Since unified source routing use MPS labels as source routing traffic engineering instructions, so unified SAM routing could seamlessly integrated with the existing MPS VPN technology by using the consistent programming instructions, that is MPS label stack. The unified SAM routing leverages the existing MPS SAM routing technology, so it can work seamlessly with the existing MPS and routing technology. It's beneficial to speed up in the development, the incremental deployment of MPS SR values. First, it's leverage existing hardware capability, such as MPS forwarding capability and MPS over UDP tunneling capability. Secondly, it facilitates the incremental deployment of MPS SR. Third, it overcomes the load balancing issue associated with MPS SR due to the readable label stack dips issue and the maximum SID dips hardware limitations. Fourth, it can seamlessly integrate with existing MPS VPN technology. Lastly, it works for both IPv4 and IPv6 underlays. Currently, Nokia has implemented this technology. Juniper and Huawei has planned to implement it. Cisco has developed a demo for this technology. That's all.
So here we have a slot to discuss both drafts. So if Jeff or Adrian, Jeff, if you want to come and have an opportunity to answer.
So I have a comment for both drafts. So,
Yes.
yep. Adrian Farrell. Hot breaking news, peace may have broken out. A group of us met at lunchtime today and planned a strategy for merging this work. That strategy has not yet been circulated amongst all the people involved, so it's not a confirmed strategy. But if it works out, then we'll be able to pull text from both documents together and have a joint author team and a unified approach, which will essentially cover the function that both of these presentations described.
I just want to mention that I missed that meeting this noon, so I have no opinion on that.
Ahmed Bashandi, Cisco Systems. I just have a comment that I mentioned in the MPLS working group. I believe, and I'm a co-author on Chahou's draft. I believe that this draft belongs here rather than MPLS because there is really nothing related to MPLS here except just taking the entropy from the source port and putting it somewhere else and back. And if this is the case, it should not, if this is the only contribution, then it should, the term segment routing should be taken out completely, write a separate draft. But this idea of putting MPLS over IP tunnel has been around for a while. And if we're talking source routing, it should be here, not in MPLS.
So I would say it's up to AD to decide really whether it belongs. It doesn't really matter, as long as work is progressing. If you think that segment routing in the name should decide, maybe. The fact that 7510 has been done in MPLS made us think that it would be more suitable place. But for the rest, we are IETF. We are not a bunch of silos. So.
Alberto Rotano, routing AD. So yes, I agree. We shouldn't be a bunch of silos. Personally, I would like to see it here. However, there has been already some discussion between the chairs here and the MPLS chairs. Now, with the latest breaking news of the potential merger of this thing, what I would like to see is, well, what is the result of that? I'm sure that we can figure out. In the end, even though I said I would like to see it here, I think that what really matters is for both working groups to be informed of the progress and to, as adoption and whatever happens after that, if anything happens, we should keep both working groups informed, regardless of where it actually happens. But, since we're talking about potential things that are not even confirmed after that meeting, then I don't think, we could make a call at any point in time today.
Wim Hendricks, Nokia. I only want to echo the fact this should be merged and as soon as possible and having one draft, because it's actually the same thing which solved. But at the end of the day, we should involve all the people involved. If we have such a discussion, we should involve all the people, authors and co-authors in it. The fact that one of them is not invited is not good. So let's merge them together as one draft and move it forward, because I think it's important work and there's no point in having two drafts addressing the same problem.
Adrian Farrell, yeah, the authors are going to go on working on this while everybody else discusses where it should be, and I'm not precious about where it should be. It clearly needs to be talked about on both mailing lists, and which working group it's in. Really, I don't care, because once it's an RFC, nobody will remember where it came from. There's plenty of history for doing spring work in, I think it's 9 other working groups now, but yeah, whatever.
So merging was logical next step, showing that we can work with each other, and this is what we should do. I mean, from technology perspective, there are some subtleties, but it's de facto same thing.
Robin from Huawei. So that's the I think that the in fact this proposed fact that is several years ago this work has been presented in Spring Working Group, but this is not be accepted by the Spring Working Group. Then it moved to MPR's Working Group. So now I think that for the SR MPRs is always some work be overlapped in both working group. So now I think this first step is try to make the achievement in the combination. So then I think this work I think don't make much more confliction. So if everyone can agree with this point, so that's my opinion.
Looks like we are all in agreement. I wasn't at the meeting.
So, Lou Anderson. So to this discussion on where it goes, currently it is a candidate for working group adoption in MPLS. It will be quite a process to get back from there. We had a kind of rough discussion between the chairs and the ADs, and the outcome was rather grudgingly, but that goes to MPLS. I have 7510 in MPLS, so that's a very related document, and I want to keep that, all the agreements that we had in the background, and that document was formed to the forefront, and these documents go through. And I'm a little bit concerned about, and it hasn't been discussed really in the two documents discussed here, but there is a service chaining document that is also a companion document to this, that could touch the special purpose labels, and I definitely want that in the MPLS working group.
One question regarding 17510. In theory, any type of IP tunnel can work. So we're not going to do it in VO3 if it's going to use a VXLAN or so. I'm not sure the type of tunnel is that important.
Ahmed Bashandi, Cisco Systems. In regard to 7510, this was did not even mention the term source routing. It was not addressing the source routing. It is addressing MPLS over UDP tunnel. This draft is something else. It says source routing over IP underlay. So that is quite different from 7510. This really, in my opinion, belongs here, not in MPLS working group.
Adrian Farrell, to Bruno's question about other tunnels, it's clear that you could tunnel MPLS SR over anything. The intent, well, certainly the intent of the authors of one document, and I think the intent of the authors of both documents, is to focus at this stage on the encapsulation that there is an immediate need for. And our suggestion is that if other encapsulations are wanted for other tunnel types, they should cause different documents.
Okay, but so far we have seen two different documents, so we are waiting for the merge maybe to know the content of the document, of the merged document.
Wim Hendricks, Nokia. Also on the tunnels, I think if we say VXLAN, I don't think it will work because you have an Ethernet header, an Ethernet. So there is limitations of what tunnels we are talking about. So I think IP tunnels, yes, but not Geneva and VXLAN and all of that stuff.
I withdraw with VXLAN, but it works equally with Jerry or on any kind of IP tunnel.
So there's a bit difference in semantics. In 7510, we use port to identify next protocol in the stack, right? So different encapsulation might use different means, but the end result is similar. However, UDP encapsulation is well defined in 7510, and it looks like most obvious one.
Hi, this is Uma from Huawei. The 2 points. First point is that tunnel encap depends on the neighboring router, which advertises what tunnel capability it has. That has been defined in IGP documents.
So it depends on actually which the egress router, which what it can handle. Depends on that. It might be that some of the tunnel types need a separate document because you have to transfer the entropy from to this thing. That is one point. And second point is in the MPLS working group, there was a discussion on whether these what you call in the picture, 2 IGP domains or 1 IGP domain. I think this draft is about 1 IGP domain because of the sRGB complications. If you move it to 2 IGP domains and tunnel it, this be extended work. I think it is better if you keep it to 1 IGP domain.
Regarding in which working group this work should be pursued, I have no strong preference. As long as Spring Working Group and the MPL Working Group can reach some consensus on this. On the other hand, if the working group, the IETF prefer to merge the two drafts, my question is whether we should repeat some details which have been described in MPL over UDP RFC again in this to be merged draft. Okay.
So Loa Anderson again. So see how that's odd. We had requests from both group of authors on both document to actually adopt the documents in the MPLS working group. And that's actually what triggered the discussion where it did go and actually where the outcome was MPLS. So if you send, you can only have it adopted in one group. It doesn't work the other way.
Yes, the bad potential result is each working group adopts a draft, but they are describing the same technology, but in different styles.
This will not happen, Shao.
What?
We won't have 2 working groups adopting each one document.
Yeah, it should be widened.
Yeah, I like to comment to Lua comment. When individual draft comes and presented to multiple working group, is not intention for the authors to be asking for adaptation from one or the other. Is asking for adaptation period. So I don't think you can imply that because it was presented in MPLS, it was like that.
One question for authors. Do you know when the two drafts would be merged, or it's too early?
None of us was present at the discussion still.
Okay.
Sergio and Beck. Which Christmas?
So my actions are today to write up the notes on the meeting we had, circulate it to the people who were at the meeting, get them to agree, circulate it to all of the co-authors, get them to agree, and then start the process of doing it. We wrote down a classically optimistic software industry plan for doing it that sees us completing our merger and posting a draft in 4 weeks. In theory, there is no reason not to achieve that, and that would then see us having a draft that could be considered for adoption before Christmas. But you know how life is.
Himanshu Shah from Siena. Since everybody's making the comments, I might as well. So my preference would be to progress it here, because if you look at the draft and what the work is, it is actually segment routing. Just because it is going over the MPLS and the IP network or one encapsulation type doesn't necessarily mean that it should be processed in the MPLS working group. So my strong preference would be to do it here.
Thank you.
Alvar, given the difference in opinions, I presume you should really comment.
Alvaro Rotana, Routing AD still. Again, we're merging this draft. We are making decisions on something that we don't know what it is yet, even though I think we have a pretty good idea. I think we should wait and see the draft, and then we can decide. I agree with Loa as well on the previous discussion that was had. If this draft, the merge draft, tends to be in the same direction, which I assume it will be, as the ones that we have here, then probably the same decision that the chairs and MPLS and Spring had gotten to should probably stand. Again, my opinion, let's wait for the merge draft, and then we can make decisions and actually talk about something we can actually see.
Sounds like a great plan.
Yeah, great. We'll do that. Next. Adriano?
Context switch. This is talking about how to achieve end-to-end segment routing connectivity between segment routing domains. So why did we even bother writing this document? There's some work in BESS, which is about a BGP, a couple of BGP extensions to enable connection across a backbone. And although the document names itself Data Center Gateway, that's an old file name, and we're really talking about connecting segment routing enabled domains. That document's just got a couple of tiny little BGP tweaks. It's a very small document, and it only talks about those protocol extensions and how to use them. It doesn't talk about the whole picture. It doesn't explain why you would be doing it and what other pieces are needed along the way. So we wrote this document, which is informational. There's no protocol definition in it to describe that problem space and to point at all of the other drafts that are out there that provide building blocks. We'll come on to that in a minute, but there's actually a large number of them to show how you use that to put it all together, and then say, oh, and by the way, one of those building blocks is that BESS draft. So what we've been told by the people in BESS is that the BESS document was quite hard to understand, not technically, but understand what the purpose was, and that this document then gave them the context and made the BESS document really easy to read. So here is a reference model that we use in the document and in some examples. What we're talking about is two segment routing domains, which are shown there as the square boxes, that are connected together by multiple potential AS paths. And for the sake of complete generality, each domain can have multiple gateways. Those gateways can be multi-homed to a single AS or to multiple ASs, and ASs themselves can be multiply interconnected. And then you want to be able to achieve, through some planning mechanism, a fully controlled end-to-end segment routing path. And two of those are shown in red and green dotted lines there, just giving you the sense of picking which gateway to use, picking which AS to use from that gateway, picking which exit point from an AS, and if there's interconnection, options, picking those, and then picking which gateway into the destination domain. The entertaining thing about this is that we're trying to achieve some traffic engineering in what would normally be a shortest path first environment. So BGP is advertising best paths normally, and what we're trying to do here is see more scope and have more level of control. So the issues and challenges that we have is how do you select which gateway to leave when there are the gateway you choose makes a difference to which paths across the backbone are available, and how do you select which remote gateway to enter a site? It's not dissimilar to a VPN problem. Our solution to that is that you make all gateways visible, all gateways to a site visible across the whole network. Then there's how do you actually select which path over the backbone to use. You don't actually need the full path, obviously. You just need the entry and exit to a domain, and the path, the tunnel across the domain could be segment routing, or it could be an MPLS tunnel or whatever. But you do need to see reachability. You do need to understand where you can get to. And as I implied, the backbone may or may not be segment routing enabled. We want to be able to support both. Classic problem, how do you identify the tunnels in the backbone, and how do you provide enough visibility of all the options and the topology to a controller without splatting the controller with absolutely every link in the networks. So here it suddenly goes into a nice small font because there are a lot of building blocks available. And in fact, an easy way to check this is to go to the references section in the draft and just see whether your favorite SR technology document is referenced, and chances are it is. What I've done here is pull out some of the key ones. So don't get offended if your favorite is not on this slide. Go check the draft itself. So we need to learn about the topology that's available, learn about the network, and BGPLS gives us that capability. So that's 7752 and the work in IDR for segment routing extensions to BGPLS. And then as a kind of sidebar to that, 7926 has lots of discussion about how you abstract a network and report the connectivity potential across that network using BGPLS up to a controller. Obviously, you need to create paths or tunnels across ASs or backbone networks or whatever, and we have mechanisms to do that in the PCE working group, which talks about PCE-initiated tunnels and the segment routing equivalent of that as well. We need to be able to bind labels to prefixes, and we have plenty of work on that. And we need to obviously assign policies for placing traffic onto paths and advertise those policies. And I think I've got the right version of the documents there, although there's been some name changing and adoption going on. And that's actually an interesting point. The draft is actually slightly out of date on name changes and needs refreshing. We need to talk about which tunnel type to use to reach a prefix. There may be options to go into LSPs or to do segment routing or whatever other tunnel. And the tunnel NCAPs document is quite handy for that. And then we need to be able to discover all the gateways to a site. Each gateway needs to know the other gateways to the site, and we need to get end-to-end advertisement of the available gateways, and that's what the BEST document covers. So I've got a worked example in just a couple of slides and a couple of steps. And so the first step is the exporting of topology and the abstraction and the building tunnels and assigning SIDs. And the little picture there is that reference architecture. And really that reference architecture maps down to the bigger picture here where the cloud networks are replaced by the available tunnels or paths, and those tunnels or paths are assigned SIDs so that you can refer to them in an end-to-end path. Having done all that, which is really a controller operation, now you can, for a given flow, you can select a path and build a SID stack. So the example here is a path that's going out of gateway 1A and back into the destination domain through gateway 3B. And you can map that through to the individual SIDs that identify that path. So that would be the fully explicit label stack, but there may be reductions on that. For example, maybe the egress domain chooses not to share its topology because it regards it just as a reachability issue. Once a packet is into that domain, it's its own responsibility. So you would shorten that stack by taking out the 402. And maybe the source domain doesn't have the full visibility across the background. Maybe it's only backbone. Maybe it's only got reachability, and that causes an even smaller stack, which gets expanded as you go. So this is an alternate version where you're going across the multi-AS path. Is otherwise the same example. Sort out your path, assign the stack, push the stack, and off you go. So where are we going with this? Some people say, listen, this is just a white paper. It's telling you how to use the various bits and pieces. Very interesting. Publish it as a white paper, move on. And actually, that's where we started. But other people are saying it's really helpful to understand how all the other IETF work fits together and therefore would be a useful archival thing. The authors have found that second point to be true in BEST, but maybe once it's written, it's done and it's served its purpose. What we plan to do is keep it alive for a bit as a framework for discussion. And it's our view, although some of that other work is happening in IDR and the IGP working groups, and even the PCE working group, this place looks like a good point to anchor the discussion of all the building blocks. I should have run away before Jeff got up.
So it is helpful having head of routing working group chair. I think our job here is not only to work on new technology, but making this technology understandable and available for people to use. So spending time and effort on explaining technology, putting different pieces together is very valuable, especially for newcomers, people who don't know the history and cannot follow everything. With regards to kind of content of the document, we've been working on packet optical gateway using segment routing semantics. So it's quite convenient to abstract semantics of LN path behind binding SID. If you try to do end-to-end LSP, you run out of label depth stack before you're there. So creating subpaths and expanding binding SID while semantics are well known to the controller looks like proper thing to do, especially from hardware capabilities perspective. And you could take MSD or maximum seed depth information and try to instantiate your binding seed anchor before you hit the limitation.
Yeah, I think that's a really good point. And, in this picture, that top tunnel that's marked L202, you clearly wouldn't want, well, clearly in my view, you wouldn't want the source controlling every hop that tunnel is taking. But even in that case, this example has got 8 labels going on, and that is probably going to be too many, and so you would scale down, as shown here, delegating some of the choices.
So another important point, and think about aggregation and IGPs, is the blast radius. If failure in one domain is propagated to another domain, you are dealing with its consistencies and bad routing in general. Binding seed provides a stable anchor point, and if another domain has a failure, most probably it would be able to recover and still provide the reachability of another path. So keeping this hidden and reducing blast radius would probably result in better network and more stable network.
Yeah, good. So please, have a more thorough look through the draft when you've got a moment, and poke us on bits that are missing or unclear.
Next is service chaining. Gaurav?
Hi, everyone. My name is Gaurav Davra. I'm Cisco Systems. On behalf of the authors and Francois Clad, who is the author of the second draft, I'm presenting the BGP-SR service chaining document and the segment routing service chaining document. Just as a reminder, we would like you to read on these documents. They are very well written. There is a good documentation about how this whole architecture is coming along. Please read the network programming, what is being done with the SRH header, and then the BGP-LS SRv6 extension, which is the base draft for which the service chaining IDR draft is extended. Problem, what we are trying to solve, what we want to do is we want to provide an alternate solution to do service chaining based on segment routing over the MPLS or SRv6 data plane. We want to provide an ability to be able to discover these services and associated service sets for those services. We also want to enable a solution which is in line with how the today's SRTE solution works, and add these services as just the elements or SIDs in that list. So the solution will be flexible. It's fully scalable, and that way we can enable the service chaining solution with the current SRT architecture which we have. Solution. So what are service functions? The way we try to define the service functions, we try to define it as the SR aware, which means it has an ability to process the traffic which is coming in with the service SID. SR unaware is we realize that not all the services will be SR aware from the get-go. So those services, we created a concept of SR proxy. So the underlying routing system act as the proxy on behalf of those service functions. And we also have the ability of these services to be discovered using a mechanism. So what is an SR proxy? There are different behaviors which we have documented in Francois' document for the service chaining based on segment routing architecture document. We have defined it as the static proxy, which is really me too. It's today's solution. Dynamic proxy, shared memory proxy, and masquerading. We I'll not be covering all of them. I'll just be covering the first two. These are described in very well details in that document, so please review it. If there is any question, we can talk over the mail list or just come talk to me. Static proxy. Static proxy is similar to what we have today, the service chaining solution, where a static information is being configured. So in this particular case, you have a VPP node which is hosting a service which is attached to it. We have a static configuration for an active SID like E1::A. The underlay is IPv6 in this particular example. And so the packet comes in with the SRH header with E1::A. And the VPP realized, oh, this is something which I have instantiated locally. It decaps the outer header, which is the IPv6 header and the SRH. It sends the packet, which is an IPv4 inner packet, to the service function. Service function does its thing. The packet comes back. You hand an inbound policy on the input interface, and that is configured to match the packet which is coming in, put the packet back, and copy over the next segment from the SRH header, which is C2::1, to the destination address and send it over the wire. So as you can see in this particular solution, it's today's concept which we have with the service chaining. The inner packet can be IPv4, IPv6, or Ethernet. We just have to maintain a chain static configuration. And one of the most important point here is, even though it's similar to the current solutions, you also still have an ability to be able to do the basic architecture of segment routing provides, like you can do SLA-based steering and stuff like that. Dynamic proxy is more advanced than static proxy. So in this particular case, the VPP is running the new code. The packet comes in. You have a local SID which is instantiated as E1::B, and it's instantiated with the function which we have defined in the service chaining architecture document as n.ad. Packet comes in. We decap the outer header, caches that information. So that's the important point here. Sends the inner bare minimum packet to the service function. Service function applies what it needs to do. The packet comes back on the ingress interface, and then it restores the IP header which was cached locally, constitutes the same SRH and IPv6 header, decrements the segment list left, which is a normal procedure, copies over the next segment, which is C2::1, into the destination address, and sends the packet out. Again, the inner packet can be IPv4, IPv6, or could be Ethernet. So it's completely stateless from that point of view. Now the important point here is that once these services which are being defined needs to be discovered to the controller. So we are proposing the BGP extensions. The base draft is this segment routing v6 BGP-LS extension document. So what we are proposing is some new sub-TLVs. So what needs to be sent? We need to send what the service type is. We need to send the SID associated with it, which is in the base TLV. We need to send the traffic type this service is capable of, which is basically an IPv4, IPv6, or Ethernet inner packet. We encode that information into this TLV, signals it through BGP-LS. If the service is in a particular VPN, we signal it in SAFI 72, else in SAFI 71. We send this information over to the controller. Also, services can have the data which we don't want to standardize on. Like, for example, vendor-specific information, brand, version. So you can have a firewall from one vendor A with a version A.B. You have another vendor Y with X.Y as a version number. We encode that information in this opaque metadata TLV and signal it to the controller. The benefit here is that only the consumer and the publisher really needs to know what the opaque type is and what the data is encoded. So it's completely opaque on the wire. From the implementation point of view, the functions which we described earlier, the proxy functions for the SR aware, are already implemented in the open source software. You can download it from the segmentrouting.net, and it's implemented on Linux kernel, and it's implemented on FTIO VPP. We also have an implementation of the static proxy, which is today's solution of how the service chaining works. A static proxy is configured as n.as function, again described in the segment routing architecture document. We have done it on Cisco hardware, so let me know if you are interested. And we are already working with academia and few other partners to aware the service chaining on the functions as the native service chaining functions. So those applications will be able to process the SR header, SR header, and also can understand the SID. In that particular case, what happens is, if you know what the SRT solution is, this function itself becomes a part of the network. So from that point on, this is a completely stateless solution, and the nodes can be auto-discovered using the BGP-LS, and then it's just another SID in the SRH header. With that, what we like to do is to seek the input. This is again an alternate solution of service chaining, which we are providing with segment routing, where you can enable, service chaining. You can still do segment routing, SLA based tiering. So we would like to seek your input and feedback, and any suggestions welcome. So let me know. Thank you.
Greg Merskiziti. I have a couple comments to the first draft. Well, you have a section that compares or discusses the relationship with the SFC architecture 7665. I think that actually that probably not very productive, because comparing approach that is similar to one that have control plane and distributed routing paradigm versus the source routing, it's like you compare oranges and apples. Yes, you have control with the source routing, but distributed routing has its own advantages. One thing that I wonder is that why not to use the terminology that established in 7665, because then it makes discussion much more easier when you use the same dictionary, because you talk of the same entities and the same functionality using your own terminology. There is a terminology.
This is not own terminology. This is a segment routing terminology.
No, but you talk about service function, right? And you have a service function forwarding. So you have all the elements that is in the reference model of SFC in 7665.
Yes, the key point is service function forwarding is no different than normal SRH operations. That's what we are saying.
Right, but
what we are saying here is that you have a SID list, which you have a SID in it, and it just forwards as it would forward with any node in the network. So there's no difference. The only thing is the discovery of those services, which we are describing over here.
Yes, but using your own terminology makes it much more difficult to compare with the other SFC solutions. Again, I'm not saying that NSH is the SFC solution. NSH, in my view, is one of SFC solutions. You present another SFC solutions. Why not to use the same terminology?
We want to align with the segment routing terminology.
And actually, I have a comment about stateless. You have some functions will be stateful. So you cannot say that your path is stateless, because otherwise you cannot support stateful service function chain.
Kyle Rose, Sandvine. Just a quick comment related to what Greg was saying about terminology. We could just have a section which maps this document onto the SFC terminology or vice versa. I mean, and that way it's clear.
Sure.
Just Ahmed Bashandi, Cisco Systems, just to reply to this, there may not be a one-to-one mapping. So maybe now, maybe later it will not. So saying that whatever Guravas is proposing must have an equivalent in SFC is not the right way we want to go. We want to use segment routing, and maybe there will be one-to-one mapping, maybe not.
I mean, the goal is to take the ideas which are needed for the service functioning to work and enable them using segment routing. So if there is a confusion about whether it's SFF or something else, it's pretty natural when you look at the overall architecture.
I guess my only concern is that, we have an architecture for service function chaining, and we spend a lot of time thinking about how to properly do service function chaining, everything that's necessary for it. And then we're saying, well, we're going to do it this different other way that isn't quite the same. It may not be the same. Are we going to make mistakes? Are we going to repeat mistakes? If we reuse the architecture, but do the implementation and the forwarding differently, then at the very least, there's just some consistency there, and that consistency is valuable.
And the goal is to create the consistency. So your point is taken. Maybe we'll compare, we'll put a table or comparison table, but as Ahmed is also saying, it may not map one-to-one. But the same idea which is needed there is enabled using segment routing.
To add to Gaurav's point, our base is segment routing, not SFC.
I'm cutting the line. Thank you.
Thank you.
Next speaker, please.
Hello, everyone. My name is Liang from China Mobile, and I'm presenting this draft for my colleague from China Mobile and Huawei Broadcom and ZTE. So this draft talks about a mechanism where you can label, provide path level label in segment routing. So problem statement. So for using segment routing MPLS, the segment path is represented as a stack of labels. But when these packets transmitted along the path, when the intermediate point start to pop up the labels, when you reach the egress point, you basically lose all these path information, and you can't identify where the packet is actually original from, which ingress point. So we do have this requirement. For example, in service provider point of view, we would like to do some measurement in path level or in path granularity, and also in terms of 1+1 protection. You may want to know exactly where the packet comes from. So we do see requirement for these type of path level marking. So we basically are proposing two options. They're methodologically, they are the same, but they have slight differences. The first option is to add a path label at the bottom of the label stack. And this label is basically assigned by the egress point or by the measurement point, which are those points where you want to take the measurement. And the label is inserted by the egress point. And it's preferred that the label is unique, where we prefer using the global label, where this basically gives you the possibility of using this label by each intermediate point. When you do a search, you can basically find out which path this packet belongs to. And the second proposal is basically to add not only a path label, but also a source label which identify the ingress point. So the path label is also assigned by the egress point, where the source label is the source label is basically assigned by the egress point, where the path label can be locally decided by the source ingress point. So these two label, additional two label, give you better, give you more label bits. So And with this 2-layer of hierarchy label, you can basically have more flexibility of labeling your path, more extendable. So in terms of use cases or application, for example, in this diagram, we basically demonstrate the first option where you only have the path label, and the upper red path is labeled by 2001, and the bottom one is 2002. So it's at the bottom layer of the labels. So when you basically can find your path or identify your path using this path label. If it is unique, if it's global, then all the node can actually use this information to identify the path. So yes, so we have noticed that not only us are looking at this problem, and there's another proposal which will be also demonstrated here after myself. So it will be worth for the working group and for everyone to have more discussion which options are going to be, fit for what kind of use cases. And yes, and we would love to hear about your comments and advices. Thank you very much.
Okay. I have a couple questions. Greg Merskiziti.
Sorry, can you? Yeah. Okay.
Greg Merskiziti. I believe that once you mentioned in the presentation the label is global, but in the text I see that it's unique within a domain.
Right.
So which one is it? Because usually when we say global, or often global means that global like IPv6 address.
No, I mean global in terms of your administrative domain. It's not globally.
Thank you. Good.
Sorry.
Thank you.
Right.
Another question is, so in the other draft that you mentioned, their purpose is to use it for on the path measurements, which is kind of okay. That's questionable how it behaves with the ECMP. But what is goal of this label? Is it label for performance measurement? So why you need to identify their path, source route path? So what to do with this information?
Right. So there's 3 use cases. I think the most sounding one, for example, if you want to do your 1+1 protection, then you have to know which path is which one. But in your egress point or any of those intermediate node, you won't know where it comes from because all the labels are popped up by the previous ones. So that's why you will need that path level identification to make your, which packet is from which path. So you have both path activated.
Yeah, actually, I agree with the performance measurement, but 1+1 protection of the CAF, I will say, put special purpose label, extra special purpose label in your working path, and don't put it in your working path. Done. Because you don't need unique identification in their domain. You just need to differentiate the working path and protection path. No?
Right. The working path and protection path may come from the same ingress node, right? And
usually, yes. 1+1, of course.
And you have to know which one is which one.
Okay, one will have extra special purpose label at the bottom. The working has extra special purpose label. That's your working path. No?
Action. So if you only use a special purpose label, you cannot identify whether this packet is from which path. You cannot. Just for all paths, for all the paths, you can put the indicator in the packet, but you cannot differentiate this packet from which path. You cannot.
I think that we can discuss it.
Well, we can have more discussion offline.
But no, I agree with the first use case, of course, because actually,
Mike, can you
some-
share the mic? Can you
Yes.
share the microphone with your colleagues behind? Thank you.
Hi, Dave Allen Erickson. First, I'd like to state that I like sort of the general direction this is going in and the problem space that it's looking to address.
Can you?
I think there's a couple of interesting aspects to this. You know, I've got some opinions in terms of, I think, what the better choices are. Of course, I'll have to hear the other draft. But certainly I'm very interested in participating in and pursuing this work.
Great. We can discuss. Yeah.
Okay.
Thank you.
Hi, Ketan Talaulikar, Cisco Systems. So yeah, hi, Ketan Talaulikar, Cisco Systems. So I think the performance measurement is right. There are existing mechanisms and it may be useful to check if we can extend them. On the 1+1 path protection, I agree that this can be done without this solution. There are existing ways to detect and trigger. On the last one as well, this is, yeah, there are again existing mechanisms, but we can look at that.
Okay.
Yeah.
Thank you.
Sorry. I just had a concern about instantiating state at the tail end exit point. So that's the reason why I have a bit of concern having these extra labels and introducing extra state where we can avoid it.
Okay.
So it feels like we expect more and more work at egress. So today we can signal amount of labels we can push at the ingress. We could signal how deep we can read with ERLD. Is there a feeling that we also need to core capabilities at egress, how many labels we can actually pop? So if you need 2 cycles to pop, it's going to be problematic, right? If there's consensus, it could be easily added to MSD as additional function, being poppable labels or something like that.
Yeah, please be quick, and I'm cutting the line between you two.
Okay.
After you two, sorry. After you.
Just a quick comment here. Regarding the first point, you're trying to do the performance management based on the segment list which you have maintained. You can do that by steering the traffic into a binding set and just doing the performance measurement that way. What is other use case here?
Sorry, I didn't hear very clearly.
It's okay. It's a long. I'll talk to you offline.
Uma, Huawei, it's very useful work, but this draft doesn't indicate how do you how each node, transit node, has to look into this last path, right? So this needs to be described, whether what is the RLD and where to put this, and also need to indicate that each transit node, why it has to look into the last node, last label. So this needs to
Right.
be addressed. Otherwise, it's a good work.
Yes, yes, we'll definitely have some more, detailed description. And I think in the draft, it actually says that it's actually described those mechanisms, but it's not very well, it's not very in detail described in the slides. Right. Thank you very much.
Good afternoon, everyone. I'm going to talk about the MPLS SR path identifiers. So let's jump into the problem space. So it's an MPLS SR network, and certain link is running hot, and we want to figure out which of the MPLS SR paths is contributing to the traffic on that particular link. So we should be able to count the traffic per MPLS SR path. So the problem here is measuring the traffic on the ingress would not be sufficient to figure out which MPLS SR path is carrying how much traffic on that link, because SR is a ECMP aware mechanism. So on every node there will be ECMP hashing, and you really don't know on a particular link for a particular SR path how much traffic is really flowing. And you won't be able to distinguish based on the label stack, because at that particular point, the labels which are inserted from the source, some of the labels might have been popped off, and you only have the remaining labels which will not be able to distinguish the path based on the label stack. So the high-level solution is to come up with a identifier, a globally unique identifier, and then put it in a packet header. So it should be possible to find this identifier in the packet header. So you really need a distinguisher to identify that there is a path identifier below this distinguishing label. And it has to be transparent to legacy implementations. So forwarding plane, legacy MPLS forwarding plane should be able to work fine with this solution. So we've come up with two options. One option where there are three additional labels getting pushed on the stack, and there is another option where two labels are getting pushed on the stack. So there is an SR path indicator label. This is a special purpose label from the MPLS reserved label space. So this implies that there are special labels below which are used for accounting and not forwarding the traffic. So the next label is a path identifier. It's a 19-bit unique label. So this could be globally unique or scoped on a node basis. So when it is scoped per node, then you have this node identifier below this path identifier. And the C bit in the second label identifies whether there is a node identifier present or not. So together with the path identifier and the node identifier is used as a key to count the traffic and then to export this information to external entities. So to save the label stack, there's also another option where you just have the path identifier. So in this case, the path identifier is a globally unique number. So all the SR paths in your network must use a globally unique number and then insert this path identifier into the packet. So you get 19 bits of a path identifier space. So if that's not sufficient, then that gives around 500,000 SR paths through your network. And if that's not sufficient, then the first option, model A, can be used to get a higher scale. So other than that, the forwarding plane procedures are pretty similar. Only thing is you look at the C bit, and then if C bit is 1, that means that you just have to use the path identifier as a key to count the traffic. So where does this special labels put up in the stack, label stack? So ideally, if we assume every node is capable of reading the label stack, whatever the ingress prepares, and every node in the network is capable of reading this label stack, then it's ideally would go at the bottom of the stack. But that is not the real deployment scenario. There could be nodes which cannot read the label stack up to the final hop. In such cases, these accounting labels have to appear multiple times, and they have to be placed in the label stack in such a way that every node in the network can be able to access it and then account the traffic. And so whenever it appears at the top of the stack, it needs to be popped off. So these labels have to be placed in such a way that nodes which understand the special label these labels appear at top of the stack only when a node get exposed at a node which can understand these labels. So we need to have an extension to IGPs to advertise the capability of this mechanism. So in certain cases, there may be sub-SR paths created in the network, basically to overcome the readable label stack depth limitation. So in such cases, the SR path accounting can be done only for the end-to-end paths and not for the subpaths, which are purely created for reducing the label stack depth purposes. So in that sense, when these SR path labels appear multiple times in the label stack, they all have to have the same identifier. So forwarding plane procedure, so when the packet arrives, if this node is configured for this kind of traffic accounting, it has to look up the path indicator label and then look up for the C bit, and then dynamically create counters corresponding to these SR path identifier and count it. And then it should stream it out periodically to external entities or whatever mechanism that is used for processing the traffic counters. So this is a difference between what is a path identifier and what is a binding SID. So the SR architecture already defines a binding SID. So the scope is like binding SID could be global scope or it could be local scope. Similarly, SR path identifier also could be global or local scope. And the purpose of binding SID is traffic steering into SR paths, whereas this purpose of this SR path identifier is traffic accounting. So generally, the action for binding SID would be pop off and replace with the label stack, whereas SR path identifier should be popped off when it appears on the top of the label stack. And binding SIDs are 20-bit and SR path identifiers are 19-bit. So this, in spite of all these differences, it's very much possible that if an operator wants to use allocate an SR path identifier and use it also as a binding SID for the policy, this should be very much possible to do.
Guys, sorry.
No.
I'm not taking any question. Sorry for that. To respect the last presentation. Sorry, Shala. It was presented in MPLS already, so you have had time to the opportunity to present it, to discuss it, and also, as Loa mentioned, that discusses special purpose labels, and Loa might want to have the discussion in MPLS as well. So please, don't even try that far. You can sit down. No, honestly, I'm burning time on the last presentation. Please. Thank you, Shraddha.
Okay, let me just lift this up a little bit. There we go. All right, left, right. All right. Hello, everyone. My name's Aaron Dukes, Cisco Systems. Talking today about segment routing and SD-WAN. So what we're looking at is, what we've looked at is SD-WAN or over-the-top VPNs and their use of a default path through the network to reach their endpoint, and how can we provide them access to some SLA paths in the network to improve their latency or select specific bandwidth to reach an endpoint. Okay, we're going to look at the forwarding and control plane, take a look at the security items. So this is a bit of a run through of the draft since this is a Rev 0. And comments and questions are welcome at the end if we have time. Okay, the basic layout here that we have is we have a SD-WAN overlay or an over-top VPN overlay, and we have some sort of SP underlay. We defined a service provider controller, which is we label an SR controller. We have an existing SD-WAN controller, common in all SD-WAN solutions that we know of. Of interest here, there's a couple of edge nodes, edge 1 and edge 2 at the top. These form the edge of the SD-WAN, and we'll get into what those guys do shortly. Okay, so typically, typically SD-WAN solution at our edge nodes or ingress edge nodes, we're going to classify some traffic, determine an egress edge node, encrypt it, send it off, and it'll get best paths or shortest path forwarding over the underlay to the egress edge node. In this case, from C1 to C2, we take the shortest path. And then at the edge of the egress node, we typically decapsulate, decrypt, and forward on to our endpoint. In this case, we got a pointer. No, I don't have a pointer. But anyway, in this case, it'd be Z as a end don't. What we've added to this is the ability for these SD-WAN edge nodes to push a binding SID. And when they push that binding SID, they'd be sending their data traffic over a secure connection or secure transport to their egress nodes, as well as their monitoring and active monitoring traffic as well, so they can measure latency or traffic loss over these transports. In the draft, we've defined for SRv6 how we do this with a binding SID, and we'd push a binding SID, and our SRH would contain both the binding SID and the egress CE address. So the binding SID at C1 then gets associated with some SLA to C2, which is the node closest to the egress node from the SD-WAN edge node. Okay, and C2 does the normal SR forwarding, where it would remove an SRH, or SRv6 forwarding in the draft, where it moves an SRH before it forwards to E2. So that gives us the ability for these ingress edge nodes to select multiple paths through this service provider network. We've also looked at requirements from the control plane on this, and the requirements for how we'd signal the need for this path to the service provider network. And I won't go into the details of that request response sort of thing, but suffice to say, the stuff on the left is SD-WAN or solution private stuff. The stuff on the right we can define with PSEP, BGP LSTE. The stuff in the middle, where we have that service request from the provider, that's new control plane work that we're going to be expanding on in future versions of this draft. And from the security side, the Spring SRv6 Network Programming Guide defines a couple of security statements, Sec1 and Sec2, that limit the ability for edge nodes, CE nodes, to be able to utilize binding SIDs or send traffic to any other SID within the service provider network. We'd extend that to include a hole so that specific edge nodes that have been allocated or allowed to use a binding SID are able to access that binding SID. A few of the benefits, you guys can read the draft on this one. Scaling, of course, these are pretty typical SR benefits. The core, the provider network maintains all the policies, binding SIDs, and maintains counters, which allow for billing. The SP doesn't share any of its topology with the CE, and the CE performs any classification it needs to do that's VPN or SD-WAN specific, and he doesn't share that with the service provider. So in this draft, we've started out with a fairly simple view of how SRv6 can be used to provide SLA paths for over-the-top VPNs and SD-WAN. With directly connected CEPs, we're going to look at the remotely connected PEs, multiple providers, using MPLS cores and using an MPLS PE to CE link in subsequent versions. And we're welcoming any collaboration, discussion, questions on the list or here at the mic.
Okay, Greg Mirsky, you mentioned latency jitter measurement. You do it on the live traffic.
Well, it depends on the edge device solution. Some of them will inject traffic in order to do that measurement over the path with the SLA, so with binding SID or with default path. Some implementations may use live traffic in order to detect that latency and jitter.
Okay, so how you identify the packet that you do measurement? You record timestamps in a packet, or you run sequence numbers in a packet?
So that'd be up to the edge node, the CE node, in order to determine how it would implement that detection. It's not the service provider that does that. So the edge nodes can run their own measurements across the SLA path, and the service provider itself separately can inject traffic across across the same policy and do its own measurements for that same path.
Okay, and
so,
and what guarantees that these packets are following the same path and are treated the same by the network?
Yeah, so there's not necessarily any guarantee that they're going to follow the same path or
Okay,
get
so
treated the same.
then
If the
performance
provider
metrics
is-
are not comparable.
Yeah,
Jeff?
strictly yes, but that's not something I was thinking of solving.
The meeting is finished. We passed the time.
Anyway, you guys could ask a question on the list, and I can go into some more of those details.
Thank you very much for your participation. Thank you for respecting the time, except maybe Adrian. And see you in London.
And one blue sheet is missing. Blue sheet.
Both services are provided. Yeah, so the trust domain in the example of the draft is the domain of trust is actually, and I didn't give it to you. The domain of trust in the draft is is limited to your PE node, right? And the direct